For this problem, we're going to estimate a population proportion from this study. So 1,000 adults 19 years of age or older were surveyed, and 259 of them confessed to bringing their cell phones to the bathroom. So in terms of the sample of the study, that would be the 1,000 adults. So I'll select C and enter in there were 1,000 adults surveyed in this study. And the population of interest means, well, it's going to apply to everybody who is 19 years of age or older. So that would be, for this one, A. The population is all adults, 19 years of age or older. Now, the variable of interest, as stated within the problem, is people who are bringing their cell phones to the bathroom. So that would be this option. And this type of variable, it's not quantitative, but it's a quality. You either do or you don't. And it's not a numerical measure, but it's based on a characteristic. Okay, so now we get to the point where we can actually come up with p hat, the point estimate for the population proportion. You take the number of successes and you divide by the total number of people surveyed. So 259 divided by 1,000. That will move the decimal point over 3 places, if you do this in a calculator, to give us a point estimate of 2.259. So this number divided by that number. So our estimate is about 25.9%. Okay, so why is this point estimate why is it a statistic? And that would be because the value is based on a sample. So it's not the whole population, but it's just a sample of the population. And why is it a random variable? Well, the value may change depending on who you ask. If you select a different 1,000 people, you might get a different p-value. So the variability comes from the people that you select. Actually, that's what the next part says here. The source of the variability depends on the individuals being selected in the study. Okay, so now this point estimate, it might not be the exact value, but we can get a confidence interval to think about where it might fall. So what I'm going to do is open StatCrunch, and I want to construct a 95% confidence interval. So we'll do this for a proportion, meaning we'll go stat, go down to proportion stats, select one sample, and then select with summary. The number of successes was 259 out of a total observations of 1,000. And we want a confidence interval, so I select here, and I see it's already set to 0.95, which is a 95% confidence interval. I'll click compute, and here we have a lower and upper limit. So what I'll do is enter in these values in here. If I round to 3 decimal places, my lower limit is 0.232, and my upper limit is 0.286. Option B seems to makes the most sense here. We are 95% confident that the actual proportion falls within the interval that we got from StatCrunch. That was 0.232, and the upper limit was 0.286. Okay, so finally, what ensures that the results of this study are representative of all adults? And of the options that we have down here, I think the best would be the fact that it was a random sample of 1,000 individuals. So the idea being, we got this point estimate, it was about 25.9% or so. That might not be the actual value, but with 95% confidence, we can say the actual proportion will fall within this range, and we can say it applies to the entire population because we have a random sample. And that is it for this problem.